Welcome back. I hope you are doing well. Now, in this series of lectures, we have started playing with numbers. In our earlier classes, we have already seen the expanded form and exponential form of a number, and we have also seen that if we have a two-digit number or three-digit number, and if we interchange the digits, and then if we add or subtract, then what happens? In today's class, I will start the divisibility of a number by different number like 2, 4, 6, 5, 10, 8, 9, 11. In today's class, we will only learn that if a number is given, then how to check, how to test that whether that number is divisible by 10 or 5 or not. So first we will start with 10 and then we will follow by 5. Before we start going to test the divisibility by 10, we will revise in brief the concept of the expanded form of a number. Suppose we have a number like 23. So how we can represent that? It can be represented as 10 multiplied by 2 plus 1 multiplied by 3, right? So at units place we are multiplying by 3 and at tens place we are multiplying by 2. So 20 plus 3, 23. Suppose we have 57, then how we can express that? It will be 10 multiplied by 5 and then 1 multiplied by 7. So at units place we are multiplying by 7, at tens place we are multiplying by 5. Now suppose if we have a three-digit number, suppose 517, then how we can express that? Since three-digit number, so we have to consider hundreds place also. So at hundred place it will be 100 multiplied by 5, then at tens place it will be 10 multiplied by 1, and that at units place it will be 1 multiplied by 7. Suppose if we have 293, then how it can be written? At units place it will be 3, then at tens place it will be 9, then they will be added, then at hundreds place it will be 100 multiplied by 2, then it will be added. So this is how we can express a number in its expanded form. So here 10 can be written as 10 to the power 1, it is 10 to the power 1. For a three-digit number, 100 means it will be 10 square, then 10 again 10 to the power 1, it will be 10 square, it will be 10 to the power 1. Now suppose if we have any four-digit number, then we will have digit at its thousands place as well. So at that time it will be 10 cube at the hundreds place. That means if we have a three-digit number like this, then it can be represented as, we can say, 10 square multiplied by c, then plus 10 to the power 1 multiplied by b, then it will be plus a. If we have four-digit number, say d, c, b, a, then it can be represented as 10 to the power 3, then multiplied by d, plus 10 square, then multiplied by c, then 10 to the power 1, this way. Now suppose if we have a longer number, say we have n number of digits, then still we can represent that as it will be multiplied by 10 to the power n, then 10 to the power n minus 1, then n minus 2, and so on. Then finally it will be 10 square multiplied by c plus 10 to the power 1 multiplied by b plus a. Now from this expanded form, if we take 10 common, then it can be further expressed as this way. Here, from here we have taken 10 common, so it will be 10 multiplied by c only, and whatever terms we have on the left of this, from there also we can take 10 common, means this, since there will be multiple of 10, so 10 will be the common factor. Now from here, from the second term, we can take again 10 common factors, so what will remain here is b, and then we will close the bracket, and since a is not multiple of 10, it is a number between 0 to 9, so we are keeping a separate. Now within this bracket, whatever we have, whatever will be the summation of all these terms, if we represent or if we express that as x, so 10 multiplied by x, and then we have the digit that we have at units place. So finally any number can be represented as 10x plus a. So this is the format of any given number. We can represent whether it is two digit number, three digit number, or any higher digit number. X will be this. So a number, when we have represented by this format, we can easily see here that other than a, whatever we have as addition with a, that means 10x. So 10x, that means it is multiplied by 10, or it is a multiple of 10, we can say. That means 10x, if we divide by 10, so that will be divisible and the remainder will be 0. So only problem is with a. So we have to focus on a, whether what will be the value of a, so that the given number will be divisible by 10. Now between 0 to 9, if we consider the digits, the 10 digits, so from 1 to 9, these are the digits which are not, or these are the numbers which are not divisible by 10. And if we divide 0 by 10, this concept we have already learned, then the quotient will be 0, right? And if we divide any number from 1 to 9 by 10, then the quotient will be 0, and the remainder will be that number itself. Only if we divide 0 by 10, the quotient will be 0 and remainder will be 0. So in that sense, since the remainder is 0 for 0, in that sense we can say 0 is divisible by 10. That means when we have a number and when we have expressed that number as 10x plus a, since 10x is the multiple of 10, so this is divisible by 10. And when we are focusing on a, then we can see here that if a is between 1 to 9, then that number will not be divisible by 10, as there will be non-zero remainder, and that remainder is that number or that digit itself. Only chance is if a has value 0, and then if we divide a by 10, then remainder will be 0. Whatever is the quotient is also 0. So that means we can say 10x plus a will be divisible by 10. That is possible if a is 0. This is the condition. That means any number which we have expressed as 10x plus a, that number will be divisible by 10 if a is 0. And if a is 0 means, that means the number that we have at units place, that has to be 0. Now we will understand this with real examples. Suppose we have a number 213. So 213 can be expressed as 2 10 to 10 square, then 1 multiplied by 10 to the power 1, then plus 3. Now if we divide 213 separately by 10, then it will be 2, then 20, then 1, 3, then it will be 1, then it will be 10, and the remainder will be 3, and the quotient is 21. That means we have a remainder 3, and that 3 we can see clearly at units place. So if in place of 3 we had 0, then easily that number could have been divided by 10. That means if it was suppose 210 instead of 213, then we could have divided that by 10. So it would have been expressed as this, then plus 0. So if at units place we have 0, then we can easily divide that number by 10. Now if we take another example, say 5179, this is our second example. So it can be represented as 5 multiplied by 10q, then 1 multiplied by 10 square, then 7 multiplied by 10, then plus 9. So here we can see that at units place we have 9. Now if we go to divide that number by 10 separately, then what result we will be getting? So what we can see here, that we have remainder 9 and we have quotient 517. That means this remainder 9 is where? This remainder 9 is matching with the digit that we have at units place. So at units place, if we had 0 in place of 9, then then the number would have been 5170. So it would have been represented as, and we could have easily divided that number by 10. So this is the condition of divisibility of any number by 10. Now here one interesting point or important point that we can also mention or we can notice here, that if we have any number and as for example, if we take the first number 213, and if the units place is not 0, if it is non-zero, then from that number if we subtract the digit that we have at units place, then that number always will be divisible by 10. So it will become 210, and 210 is divisible by 10. And from the concept that we have learned just now, at units place now it is 0, so it must be divisible by 10. Now again, if we take this example 5179, so from that number if we subtract 9, 5179, 9 we have at units place, so it will become 5170, and 5170 has to be divided by 10 as it has 0 at units place. So if any number that which is given at units place, if we see that the digit is 0, then that number is divisible by 10. And if we see that at units place the number is non-zero, then if we subtract that digit from the given number, then that number has to be divisible by 10. So this is the whole concept of a number's divisibility by 10. Next we will see the logic of divisibility by 5. Now again we take the general format of a number when we represented or expressed that number in expanded form. Then it will be plus 10 c we have at hundreds place, so 10 square multiplied by c, then it will be 10 multiplied by b, then plus a. So we have seen already this format, 10x plus a. Now 10x is multiple of 10, that means it can be divided by 10. And if we take the factors of 10, then it will be 2 multiplied by 5. So the factors are 2 and 5. If we exclude the factors 1 and 10, because any number if we consider, then that number will have at least 2 factors, 1 and that number itself. So if we exclude those 2 factors, then the other 2 factors that 10 can have are 2 and 5. So a number which is divisible by 10, that will be also divisible by 2, and that will be also divisible by 5, right? So a number like say 20, we know this is divisible by 10. If we divide 20 by 10, then it will be 20 and then there will be no remainder. Similarly, if we divide 20 by 2, then again there will be no remainder. If we divide 20 by 5, then it will be 5 4s are 20, there will be no remainder. That means any number which is divisible by 10, that will be divisible by the factors that 10 has, other than the 1 and that number itself, means 2 and 5. And that is applicable for any other number also. So a number which is divisible by some other number, so that will be divisible by the factors of the second number as well. That means 10x, since we have already proved that 10x is divisible by 10, so that will be divisible by 5 also. So we have no problem with 10x. Now only focus that we will have is on a. So what would be the value of the digit that we have at units place so that the given number will be divisible by 5? Now the value a that we have at units place, it can have values 0 to 9. Now if we consider 1, 2, 3, 4, 6, 7, 8 and 9, these are the numbers which are not divisible by 5, we know. And there is a number 5 which is divisible by 5, because 5 if we divide by 5, then quotient will be 1 and remainder will be 0. And there is a special number, always 0 can be divided by any number. So if we divide 0 by 5, then the quotient will be 0 and also the remainder will be 0. Since remainder is 0, so in that sense we can say 0 is divisible by 5. Otherwise, if we pick any other number from this list, suppose 7. Now if we divide 7 by 5, then it will be, quotient will be 1, but the remainder will be 2. So there will be always a non-zero remainder if we divide these numbers by 5. That means from 0 to 9, there are only two digits, two numbers, 0 and 5, which are divisible by 5, and there will be no remainder. That means in this format 10x plus a will have only 0 and 5, these two values, for the number to be divisible by 5. Now if we take examples, then it will be more clear. So our format is 10x plus a. Now suppose if we have a number 583, we have to see whether that number is divisible by 5 or not. Then 5, it will be 5 multiplied by 100, then it will be 8 multiplied by 10, and then 3. 5 multiplied by 100, this is divisible by 5. As we have a factor 100, then it has to be divisible by 5 as well. 8 multiplied by 10, so this has to be divisible by 5. And then we have at units place 3. Since 3 is not divisible by 5, the remainder is 3. So the given number 583 is not divisible by 5. Now suppose if we take a number 180. So 180 means it can be expressed as 1 multiplied by 100, then 8 multiplied by 10, and then 0. This number, this part is divisible by 5, this part is divisible by 5, and 0 is also divisible by 5. Since if we divide 0 by 5, the remainder will be 0 only. So the whole number 180 will be divisible by 5. Now if we take another example, say 755, then what will happen? Then 7, it can be expressed as 7 multiplied by 100, then 5 multiplied by 10, and then 5. 7 multiplied by 100 is separately divisible by 5. 5 multiplied by 10 is separately divisible by 5, and 5 is also divisible by 5. So the whole number 755 is divisible by 5. So this is the concept of divisibility by 5. So at units place, if we have 0 and 5, then only the whole number will be divisible by 5, otherwise not. It will give us a non-zero remainder. Now we have to see that if a given number is not divisible by 5, then what could be the remainder of that number? Now here we have seen that 583, till this point it was divisible by 5, and only the digit that we have at units place, that part was not divisible by 5, and when separately we divided that, the remainder came as 3. So from this number, if we subtract 3, then the whole number will be divisible by 5. Now 1, 2, 3, 4, among these numbers, if we divide any of them by 5, then the remainder will be that number itself, as these numbers are less than 5. And 6, 7, 8, 9, all these numbers are more than 5. So if we divide these numbers, then the remainder will be the subtraction of this number and 5. How? If we divide 6 by 5, then it will be, the quotient will be 1 and the remainder will be 1. So 6 minus 5 is 1, right? Now if we divide 8 by 5, then the quotient will be 1 and the remainder will be 3. So 8 minus 5 is equal to 3. So from this list, which are more than 5, which are greater than 5, from this list, if we divide any number, if we choose any number and divide by 5, then the remainder will be the difference between that number and 5. Otherwise the remainder will be that number itself. And if it is 0 and 5, we know these two numbers are divisible by 5. So if at units place, if we have these two digits, then no problem. Now if we take another example, say 289, then we have to see whether that number is divisible by 5 or not. 289 means 2 multiplied by 100, then 8 multiplied by 10, and then 9. This part is divisible by 5. This part also separately, if we divide, then that can be divided by 5, and the digit that we have at units place, 9. Since 9 cannot be divided by 5, so this whole number 289 is not divisible by 5. Then we have to see then how much will be the remainder. So 289, if we divide by 5, then it will be 5 5s are 25, then we have 3 9, 5 7s are 35, then it will be 4. So here the quotient is 57 and the remainder is 4. And if we divide 9 separately by 5, then it will be again 1, then here it will be 5 and the remainder will be 4. So we can conclude here that a given number which is not divisible by 5, the remainder of that number will be same as the remainder if we divide the digit at units place by 5. So if we take another example, say 7 1 then 8. So 7 1 8 can be represented as 7 multiplied by 100, then 1 multiplied by 10, and here 8. These two terms can be separately divided by 5, but since we have 8 which is not divisible by 5, so whole number 718 is not divisible by 5. So what will be the remainder now? 718, if we divide separately, then it will be, the remainder is 3. And if we divide 8 separately by 5, then also the remainder will be 3. That means at unit place, whatever number we have, whatever digit we have, if we divide separately that, the remainder will be same as when we will divide the number by whole number by 5. Now there is another interesting point, that if the remainder is given, then how we can say that what could be the last digit of that number which is not divisible by 5 or maybe divisible by 5. If the last digit is 0 and 5, then the remainder will be always 0. So we are not going to those numbers which are divisible by 5. We are taking, for example, those numbers which are not divisible by 5. Now suppose if the remainder is given as 2, then by looking at this 2 which is given as remainder, how we can say what could be the last digit of the whole number. Since here the remainder is 2, so we know that the remainder will be same as when we will divide the last digit, the digit that we have at units place, separately by 5, and that will be same. So here the remainder, if it is 2, then the last digit could be 2, or it could be 2 plus 5 7, because when we divide 7 by 5, then in that case also the remainder is 2. So by looking at the remainder, this is the way how we can conclude that what could be the last digit of that number, or the digit at what we can have at units place. So if it is 2, then it could be 2, or 2 plus 5 7. Now suppose if it is 4, then it could be, the last digit could be 4, or 4 plus 5 9. So this is the way how we can check the divisibility of a number by 10 and 5. In the next class, we will see the divisibility rule by some other number. Till then, thank you.